Hello everybody, today we are looking at section 7.3, applications of the dot product. So we're going to look at two applications today. One, which we talked about actually last lesson, is work. Okay, so work in geometric form is the magnitude of the force times the magnitude of the displacement times the angle between them, cos theta. Algebraically, if the two vectors are given in algebraic or Cartesian form, okay, that means that there's no angle between them, they're just like their xy components, then the work is the dot product of force and displacement. Okay, so now if we put these two together, right, what we get is force, there we go, force dot displacement is equal to the magnitude of force times the magnitude of displacement times cos theta. Okay, now we can rearrange this and get F dot D divided by F D is equal to cos theta. And this allows you to find the angles between vectors. Okay, and this is what like a computer program would use to figure out angles between vectors, right? So first example here, determine the angle between vectors A and B. Okay, so we just use the formula, cos theta is equal to, right, F dot D, so we're going to take the A dot B over the magnitude of A times the magnitude of B. Okay, and just recall, we just multiply the x coordinates, so 4 times 3 is 12, and then negative 2 times 4 is negative 8, 12 and negative 8 make 4. And then the magnitude of a vector, remember, just Pythagorean theorem, is the square root of the x coordinate squared plus the y coordinate squared. And same thing for vector b. So we get cos theta is equal to this number here. And we just do inverse cos, and we get the angle between the two vectors when they're tail to tail, of course, is 80 degrees. Perfect. Okay, we're also going to look at projections. Okay, so a projection is, so if I have a vector A and a vector B, the projection of A onto B is just when you drop it straight down, that is the length of the vector, that's the projection. Okay, so it's almost like velocity of an airplane. The airplane's going this direction here, and horizontally it's going that fast, and then vertically it's going that fast. So the projection is the length of that vector there. So the magnitude, so again, magnitude just means we're not worried about a direction or anything. So the magnitude of the projection of A onto B, so remember A is written on like above B, so A on B is equal to the magnitude of A times cos theta. Okay, and this is just SOHCAHTOA, right? Because cos theta is equal to the adjacent, which is your projection, divided by the hypotenuse, which is A, and then we just multiply across there. Okay, good. So algebraic vectors, there's no angle provided, so the projection of A onto B is equal to, again, it's A times cos theta, but cos theta is equal to this right here, and that's the formula from above. Okay, so it's A dot B, or the magnitude of A, the magnitude of B, and then if we look here, we cross out the A and the A, and we get that the projection is A dot B over the magnitude of B. Okay, so example, determine the projection of A, the magnitude of the projection of A onto B. So again, it's A dot B divided by the magnitude of B. 6 times 4 plus 1 times 3 over the square root of 25, which is 27 over 5. Or you can put it as 5.4 if you'd like. I just drew a diagram to show you what it looks like. Okay, now part B, this is a little bit different. Determine the projection with direction. So that's going to give us a vector result rather than just a scalar like that. Okay, so the way that we do this is once we get our answer, okay, we just multiply it by a unit vector of B. So what the unit vector is, it's a vector in the same direction of B, with a length of 1. So I'll just draw in the diagram above. So approximately this would be the unit vector, and we represent it as a b hat. Okay, so the way you get any unit vector, the way you create any vector, is you simply take the vector and divide it by its magnitude. So I'll just do it on the side here. So for vector b is 4, 3. So if we take 4 and 3, and we divide this by its magnitude, okay, again, we figured out the magnitude is 4 squared plus 3 squared rooted, which is 5. Okay, this vector, I can write it like this now, if you wish, 4 over 5, comma, 3 over 5. Okay, is in the direction of b, but it has a magnitude of 1, and I'll prove it. So let's do the magnitude. So it's going to be 4 over 5 squared plus 3 over 5 squared, and then we're going to square root it. So we get 16 over 25 plus 9 over 25 square rooted, and that is 25 over 25, which is 1. Okay, so it works with every vector. You just take a vector, divide it by its magnitude, you create a new vector in the direction, but a magnitude of 1. So what we do now is we take our projection and we're multiplying it by this vector here. Okay, so in doing so, we're going to manipulate a little bit. So we're going to multiply the magnitude of b. Okay, it's just loading here. Give me a second here. Okay, so we have the magnitude of b and the magnitude of b here. So we multiply those together, we get the magnitude of b squared. And the magnitude of b squared, okay, is simply b1 squared plus b2 squared. Okay, and that's the same as saying b1 comma b2 dot b1 comma b2. So the magnitude of b squared is simply b dot b. Okay, so the magnitude of b squared is equal to b dot b. All right, so we're going to go ahead and do what we just did earlier, and we're going to take our vector here. So we get 61.43 over 43.43. We get 25 over 27. And we're going to multiply that by vector b, which is 4 comma 3. And here is our answer. So that's the projection with direction. Okay, now note, if the angle between A and B is between 90 and 180, the projection is negative. And we talked about this last unit. And there is your homework for today.